James Webb may have uncovered signs of a liquid metal ocean hidden beneath a rogue planet wandering through empty space without any star. That sounds impossible, yet fresh observations have pushed scientists toward an idea few expected. If this holds up, everything we thought we knew about lonely worlds could change forever. If you're enjoying this, subscribe so we can uncover what James Webb found next together. Now, here's where everything gets even stranger. This frozen traveler shouldn't have enough energy for anything like an ocean, yet something deep inside refuses to cool down. That's where our story truly begins. A planet without a sunrise sounds like something from science fiction, yet rogue planets are real. Unlike Earth, Mars, or Jupiter, these worlds don't circle any star. They drift alone through the darkness between solar systems, carrying whatever heat they were born with and almost nothing from the outside. For years, many scientists pictured them as frozen, lifeless balls of rock or gas slowly cooling forever. Then James Webb took a closer look at one unusual target, and the story changed almost overnight. The telescope didn't capture crashing waves or shining rivers. Instead, it measured tiny changes in infrared light, the kind of light our eyes can't see but warm objects naturally give off. Those faint signals hinted that something deep below the surface wasn't behaving like a cold world at all. Hidden beneath thick layers of rock and crushing pressure, an enormous sea of molten metal suddenly became one possible explanation. If that sounds unbelievable, you're not alone. Researchers were surprised too. Think about what that really means. Oceans usually make us picture water stretching across a beach under blue skies. This wasn't water. This wasn't even close. Scientists were asking whether a huge layer of liquid iron mixed with other heavy elements could still be flowing beneath a planet that had no nearby sun keeping it warm. That idea raised an even bigger question. Where could all that heat possibly come from? Before we answer that, we need to understand why finding a rogue planet is already incredibly difficult. These lonely worlds don't shine the way stars do. Most only reveal themselves through the faint warmth they slowly release into space. Detecting one is like trying to spot a tiny glowing coal floating across an endless black ocean from thousands of miles away. It takes extraordinary instruments, careful measurements, and plenty of patience. James Webb was built for exactly that kind of challenge. Its powerful infrared instruments can detect heat that other telescopes would easily miss. Instead of looking for visible light, Webb studies invisible energy, allowing scientists to examine objects hidden inside thick clouds of dust or wandering through the darkest regions of space. Every observation adds another small piece to a much larger puzzle. At first, the strange heat coming from this rogue planet didn't seem to fit the usual picture. The reading suggested the interior could still be far more active than expected. One explanation pointed toward radioactive elements slowly releasing energy. Another suggested leftover heat trapped since the planet first formed. Neither answer completely solved the mystery. Something deeper still seemed to be happening. And once James Webb gathered another round of observations, the evidence became even harder to ignore. The telescope wasn't taking ordinary pictures. It was breaking the planet's faint light into tiny pieces, almost like separating sunlight into a rainbow. Every slice carried hidden clues about temperature, chemistry, and what might be happening far below the surface. Scientists weren't looking for a metal ocean when they started. The data slowly pushed them toward that possibility. One reading showed the planet was holding onto more internal heat than expected. Another hinted that its deep interior wasn't cooling the way normal models predicted. On their own, those results weren't enough to prove anything. Together, though, they painted a picture that refused to fit the old ideas. Something inside this wandering world seemed to be staying hot, even after drifting through deep space without a parent star for what could have been billions of years. That's where things became truly exciting. Planetary scientists already knew that enormous pressure can keep materials behaving in surprising ways. Deep inside Earth, iron is squeezed so hard that it flows despite being buried beneath thousands of miles of solid rock. Could something similar be happening inside this rogue planet? If so, the liquid layer wouldn't be made of water at all. It could be a vast ocean of molten metal slowly moving beneath an icy outer shell. Before we go any further, take 1 second to subscribe if you enjoy space stories backed by real science. We dive into discoveries like this all the time, and the next reveal completely changes how this mysterious planet may have survived for so long. Even with Webb's remarkable abilities, scientists had to be careful. Telescopes don't directly see underground oceans. They collect light. Researchers then compare those observations with detailed computer models, testing thousands of possible interiors until the closest match begins to appear. Every new calculation removed some explanations while strengthening others. Frozen rock alone didn't fully explain the signals. A simple gas giant model also fell short. The idea of a deep metallic layer kept returning. Still, one huge problem remained. A liquid metal ocean needs an enormous amount of energy to stay molten. Without sunlight warming the planet, where was that energy coming from? Leftover heat from its violent birth might explain part of it. Slow radioactive decay inside the core could add more. Powerful pressure from the planet's own gravity might also trap heat for extraordinary lengths of time. Yet none of those answers completely settled the debate. Then researchers noticed another detail hidden inside Webb's observations. It didn't prove the ocean existed. Instead, it suggested the planet's interior could be even more active than anyone first imagined. And if that interpretation turns out to be correct, the discovery won't just rewrite what we know about rogue planets. It could force scientists to rethink how entire worlds survive in the coldest places imaginable. That's when the strongest evidence finally came into view. After comparing every observation with thousands of computer models, one possibility kept rising to the top. Deep beneath the frozen outer layers, this rogue planet might contain an enormous ocean of liquid metal. Not water, not lava. Molten iron mixed with other heavy elements flowing under crushing pressure. If that interpretation is correct, James Webb may have helped uncover one of the strangest worlds ever studied. At first, the idea sounds impossible. How can metal stay liquid on a planet that drifts through space without any nearby sun? The answer isn't simple because sunlight isn't the only source of heat a planet can have. Scientists think some worlds trap leftover energy from the violent collisions that formed them billions of years ago. Radioactive elements buried deep inside can also release heat, very slowly for incredibly long periods. Add the crushing weight of an entire planet pressing inward, and the deep interior can remain far hotter than the frozen surface above. Earth offers a small clue. Our planet has a liquid outer core made mostly of iron and nickel. Even though the ground beneath our feet feels solid, thousands of miles below us, molten metal is constantly moving. Those powerful flows help create Earth's magnetic field. Now imagine a much larger metallic layer hidden inside a lonely world with no sunrise, no sunset, and no starlighting its sky. That's the possibility scientists are now exploring. Think about that for a second. Everything on the surface could look cold and lifeless, while an enormous metallic ocean slowly churns underneath. From the outside, the planet would appear quiet. Deep below, it could still be active. That contrast is exactly what makes this discovery so fascinating. The darkest worlds in the galaxy may not be as dead as they first appear. Of course, researchers aren't declaring victory yet. James Webb cannot directly photograph an underground ocean. Instead, it measures light, heat, and chemical fingerprints. Scientists then compare those measurements with detailed physical models to see which explanation fits best. Right now, the liquid metal ocean hypothesis is one of the strongest possibilities, but it still has to survive more testing and future observations before it can be confirmed. Even so, if this idea proves correct, the discovery reaches far beyond a single rogue planet. It suggests that hidden internal oceans made of molten metal may exist inside other wandering worlds as well. That would force astronomers to rethink how planets cool, how they generate magnetic fields, and how long they can stay active after losing their parent stars. But the biggest surprise wasn't the possible ocean itself. It was what that ocean might allow this mysterious world to keep doing long after every scientist expected it to become completely cold and silent. If a vast layer of molten metal is still moving today, then this planet isn't simply surviving. It could still be changing from the inside out. That's a huge shift in how scientists think about rogue planets, because they were once seen as frozen leftovers with very little happening beneath their surfaces. Moving metal does more than stay hot. On Earth, the slow flow of liquid iron inside the core creates our magnetic field. That invisible shield protects our planet from harmful radiation coming from space. Naturally, researchers began asking another question. Could a rogue planet with a metallic ocean generate its own magnetic field too? Nobody knows yet, but the possibility is exciting, because it means these lonely worlds may be far more active than anyone imagined. Now, here's the detail almost nobody is talking about. If this planet really has an active interior, it could remain geologically alive for billions of years without receiving energy from a nearby star. Instead of depending on sunlight, it would rely on heat, locked deep inside since the day it formed. That changes everything, because astronomers have traditionally linked planetary activity with stars. Suddenly, a world drifting through complete darkness might still have an engine running beneath its frozen shell. Think about that for a second. A planet doesn't necessarily need bright sunshine to stay interesting. It may only need enough hidden energy trapped below its surface. That simple idea opens the door to an entirely new way of looking at planets scattered across our galaxy. Instead of searching only around stars, scientists may need to pay much closer attention to the countless wandering worlds floating alone through interstellar space. There could be far more of them than planets orbiting suns. Of course, that creates another mystery. If one rogue planet can keep its interior alive for so long, how many others are doing exactly the same thing? Astronomers estimate that our galaxy could contain billions of rogue planets. Even if only a small fraction have metallic oceans, the number would still be astonishing. Hidden beneath frozen crusts, these worlds might have been quietly evolving while nobody even knew they existed. But here's where the story takes another unexpected turn. A liquid metal ocean doesn't simply stay underground forever. As it slowly moves, it can influence everything above it, from the planet's magnetic behavior to the way heat escapes through the crust. Those tiny changes may leave fingerprints that telescopes like James Webb can detect from unimaginable distances. In other words, scientists aren't just guessing anymore. They're learning how to read clues hidden inside light itself. And that's exactly why the next discovery could become the most surprising part of this entire story. Because researchers have already started asking whether this strange planet is unique, or simply the first member of a much larger hidden family waiting to be found. That question has pushed scientists into one of the biggest debates in modern planetary science. Is James Webb really seeing signs of a liquid metal ocean, or could something else be creating the same signals? At first glance, the answer seems simple. Build a computer model, compare it with the telescope's observations, and pick the best match. Real science rarely works that way. Every model depends on assumptions about the planet's size, age, composition, and internal structure. Change just one of those details, and the final result can look very different. That's where the mystery grows even deeper. Some researchers argue that trapped heat from the planet's birth may explain everything without requiring a giant metallic ocean. Others believe radioactive elements buried inside could keep the interior warmer than expected for billions of years. A third group thinks both ideas may be working together. None of those explanations has been ruled out completely, and that's exactly why the debate is so exciting. Every new observation removes one possibility while making another stronger. Now stop and think about what that means. Scientists aren't arguing because the data is weak. They're arguing because the data is strong enough to support more than one realistic explanation. That's a very different problem. Instead of asking whether something unusual exists, they're asking what kind of unusual world they're actually looking at. The answer could change how astronomers describe rogue planets for decades to come. But here's the detail that changes everything. James Webb is still collecting new observations. Every fresh set of measurements gives researchers another chance to test their ideas against reality. If the next observations match the liquid metal ocean models again, confidence in that explanation will grow. If they don't, scientists will have to rethink everything from the beginning. That's how discovery works. Every answer has to survive another test. So does that mean the mystery is close to being solved? Not even close. In many ways, this story is only beginning. The more Webb observes, the more questions appear. Could this planet still have volcanic activity hidden beneath its frozen crust? Is its interior producing a magnetic field? How large is the suspected metallic ocean? Nobody can answer those questions with certainty yet, but researchers now know exactly what to look for. And that's why astronomers are becoming increasingly interested in other rogue planets scattered across the galaxy. If another wandering world shows the same strange fingerprints, this discovery will no longer be an isolated mystery. It will become evidence that entire populations of hidden planets may be far more active than anyone ever imagined, which raises one final question before this story comes to its conclusion. What if this lonely planet isn't the exception at all, but the first glimpse of a completely unseen class of worlds hiding in the darkness between the stars? That possibility has astronomers thinking far beyond a single discovery. If one rogue planet can hide an active interior for billions of years, there may be countless others doing exactly the same thing without anyone noticing. The universe could be filled with wandering worlds, carrying secrets we've never even imagined. That idea changes where scientists may look next. For decades, the biggest search has focused on planets orbiting stars because sunlight makes them easier to detect. Rogue planets were often treated as interesting, but not especially important. James Webb may be changing that view. If hidden heat can keep these lonely worlds active, then every new rogue planet becomes another chance to uncover something extraordinary. But here's where the story takes another unexpected turn. Researchers are beginning to wonder whether a metallic ocean is only one piece of a much larger puzzle. A moving layer of molten iron could create a magnetic field, and a magnetic field could influence how heat escapes from deep below the surface. That process might leave tiny signals that powerful telescopes can detect across unimaginable distances. Instead of seeing the ocean directly, scientists could be reading its fingerprints from light that has traveled for years through space. Think about that for a second. Everything we know about this hidden world comes from light. No spacecraft has landed there, no probe has drilled beneath its frozen crust. Every conclusion comes from careful observations, detailed physics, and computer models that must agree with one another. That's what makes this investigation so remarkable. Scientists are learning about an underground ocean on a planet floating alone between stars without ever touching its surface. Of course, another question naturally follows. If these hidden worlds are so difficult to find, how many have escaped our attention already? Some estimates suggest rogue planets may outnumber the stars in our own galaxy. Even if only a small number have active interiors, that still represents an enormous population waiting to be explored. Suddenly, empty space doesn't seem quite so empty anymore. Now here's the part that makes this discovery even more exciting. James Webb wasn't designed only to answer old questions. It was built to reveal things nobody expected to find. Again and again, the telescope has uncovered objects that challenge long-standing ideas about how the universe works. This mysterious rogue planet may become another example of that pattern. Every new observation pushes scientists to improve their models, rethink old assumptions, and ask better questions than before. And those questions are already leading toward the next major breakthrough. Researchers aren't simply trying to confirm whether a liquid metal ocean exists. They're trying to understand what that ocean could tell us about the hidden lives of planets scattered across the galaxy. Because if this wandering world really is the first of its kind, then the next discovery won't just add another strange planet to the list. It could reveal that we've been overlooking an entire population of active worlds hiding in plain sight all along. That possibility is exactly why astronomers aren't treating this as just another interesting observation. They're already planning new studies to test whether the signals James Webb detected truly point toward a liquid metal ocean, or whether an entirely different explanation is waiting to be discovered. Either outcome would reshape what we know about rogue planets. So how do scientists move from a strong idea to real confidence? They don't rely on a single observation. They return to the same object again and again, collecting fresh measurements under different conditions. Every new dataset is compared with earlier results. If the same unusual patterns keep appearing, the leading explanation becomes stronger. If the evidence changes, the models must change too. That's how science slowly separates exciting possibilities from lasting discoveries. Here's the part that makes the wait worthwhile. James Webb is still one of the most powerful space telescopes ever built, but it won't work alone forever. Future observatories will bring sharper instruments, better detectors, and new ways to study distant planets. Together, they could reveal details that are impossible to measure today. Instead of asking whether a metallic ocean might exist, researchers may eventually estimate its depth, its temperature, and even how fast it moves beneath the frozen crust. Imagine reaching that point. A world drifting through complete darkness could become one of the best places to understand how planets survive without sunlight. Every answer would help scientists improve their theories about planetary formation, internal heat, and magnetic fields. Those discoveries wouldn't only explain one lonely object. They would help us understand countless others that may still be invisible to us. But another question refuses to go away. If rogue planets can stay active for billions of years, could some of them be far more complex than anyone has imagined? Scientists aren't claiming that today because the evidence simply isn't there. Still, history has shown that every major telescope eventually finds something nobody predicted. James Webb has already surprised astronomers many times, and this mysterious world may not be its final shock. That brings us back to the beginning of this journey. A strange heat signature led to an extraordinary idea. That idea became a serious scientific investigation. Now every new observation has the chance to strengthen or challenge the liquid metal ocean hypothesis. The story isn't ending because one answer has been found. It's continuing because the evidence keeps asking bigger questions. And perhaps the biggest one of all is still waiting. If one wandering planet has already forced scientists to rethink what is possible, what happens when James Webb discovers another one showing the very same fingerprints? That moment wouldn't simply confirm an unusual planet. It would suggest the galaxy has been hiding an entire class of extraordinary worlds, quietly drifting through the darkness while humanity looked somewhere else. That final possibility is exactly why astronomers can't stop watching. A single rogue planet has already challenged ideas that seemed settled for decades. What began as an unusual heat signature has grown into one of the most fascinating investigations in modern astronomy. If the liquid metal ocean hypothesis survives future testing, this lonely world won't simply become another entry in a catalog. It could become the first known example of an entirely new kind of planet. Looking back, every step in this story followed the evidence. Scientists found a planet drifting through space without a parent star. James Webb detected unexpected heat. Careful analysis suggested the interior might still be active. Computer models pointed toward a deep layer of molten metal as one of the strongest explanations. None of those discoveries happened overnight. Each answer opened another question, and each question pushed researchers deeper into the mystery. Here's the detail that deserves the most attention. The biggest discovery may not be the ocean itself. It may be the realization that we've underestimated what planets can do after they lose their stars. For years, many people imagined rogue planets as frozen worlds, with little chance of surprising anyone. Now that picture is beginning to change. Hidden energy, trapped for billions of years, may allow some of these worlds to remain active long after they should have gone cold. Think about that for a second. Somewhere in the darkness between the stars, there could be countless planets carrying secrets nobody has uncovered yet. We can't see most of them directly. We can't visit them with today's technology. Yet by studying tiny amounts of light crossing unimaginable distances, scientists are slowly uncovering their stories. That's one of the most remarkable parts of astronomy. The universe often reveals its greatest secrets through its faintest signals. Of course, one important mystery still remains. Is this rogue planet truly hiding a vast liquid metal ocean? Or are scientists looking at another process that behaves in almost the same way? Right now, nobody can honestly give a final answer. That's not a weakness of science. It's one of its greatest strengths. Researchers keep testing ideas until the evidence leaves no room for doubt. History shows that many of the biggest discoveries began exactly like this. A strange observation challenged an old belief. Better instruments gathered better data. Fresh ideas replaced outdated ones. James Webb is following that same path today, revealing a universe far stranger than anyone expected only a few years ago. So the next time you look up at the night sky, remember this. The brightest stars aren't the only places where incredible stories exist. Far beyond their light, invisible worlds may be wandering through endless darkness with molten oceans hidden beneath frozen shells, quietly waiting for humanity to notice them. And perhaps the greatest discovery James Webb will ever make isn't proving that this mysterious ocean exists. It may be showing us that the universe still holds countless surprises, and we've only just begun to find them. James Webb hasn't given us every answer yet, but it has shown us where to keep looking. If this hidden metal ocean is real, countless more could be waiting in the darkness. Subscribe for the next discovery and tell me below. Ocean